the one, the only, the Kanye West of Cinema 4D, Thanassis. No. So, AKA Noseman, he's been a long-time contributor to the community, a huge educator. Check him out if you have any questions. I've learned so much from him, and he's going to be going over some of the new features in R21. And I've heard there's, about Bevel. I haven't got a chance to check it out, internet, so sorry. I'll let you take it from here, and I'm really excited because this is my first real look at 21. So thank you, brother.
Thank you, Matthias. So good morning. Wow, we've got about 1,600 people here. I'm actually pretending. But anyhow, I think there are more people awake watching this than the Super Bowl final. Anyway, so I'm Athanasios Pozantzis. Athanasios means immortal in ancient Greek, and I plan to live up to my name. There's only a handful of Pozantzis on this planet. I'm called Noseman, that's my handle. And you can find me on Twitter, where I very rarely tweet, but nonetheless, all my tweets are very ingenious. So today I'm going to show you some of the R21 features. I'm very excited about this release, and it has as many, let's say, front-facing features as back-end features. So there have been many improvements under the hood, which you're going to see when you start working with it. But I'm just going to focus on a handful of features. For various reasons. One is that I haven't had so much time to investigate them, so I apologize beforehand, but I do promise that, let's do this. I'm going to press V, and I'm going to go to over here. So sign up on cineversity.com, watch us on c4dlive.com, which you actually are doing right now, but that was a slight oversight from me. I started writing this at 5:30 in the morning. And Maxon's YouTube channel has a lot of great content for you. So let's move on to the next slide. These are my slides, by the way. Intro. So today, these are sort of the features we're going to look into. Number one, the Intel Denoiser now has been incorporated inside Cinema for the R21 and allows you, with a bit of a complex setup, which I'm going to show you, to denoise things. It'll take you some time to get used to it, but it does work. Caps and bevels, and by the way, sarcasm is always built in my presentation, so don't take anything I say for granted, okay? Just read between the lines. Caps and bevels, a new capping and beveling system for our generators, our spline generators. There's some standard particle speed improvements and a few more particle stuff you're going to have a lot of fun working with. And I think quite a few of our tutorial makers and resident Cinema 4D users are preparing a number of tutorials on these things. Like the field force is one of them we're going to see today. We have a new auto-weighting algorithm which allows people that are not character animators per se, with just one click, to get significantly better results. And you don't have to fiddle with any weight painting and stuff like that. And there's a very significant field workflow improvement, which everyone is going to love, including subfields, masking fields, and so forth. Anyhow, so let's move forward. This is just a small sample of a huge list of various improvements. And this is the full list of improvements, which is cut down so you can read it. And I'm going to show it back. I'm going to show it again at the end, so you know exactly what we're talking about. Yeah, anyway, so I think I can stop that now and close it. So without further ado, let's begin. So first of all, let's go to my folder and open up the Stylus Watch. Now this is it's content from the content browser made by a great artist, one of my, actually my favorite hard surface modeler, Glenn Johnson. He's around here if you want to talk to him. He's like a homo universalis of modeling and shading. He's absolutely magnificent. So usually what we have here is a situation, because we're using a physical render, especially on my 2014 MacBook Pro or my 2010 Mac Pro, which is basically my kit, and a $300 PC. That's what I work with. It's quite slow to render. So in this case, what I'm going to do is I've got physical render, I've set it to progressive, and I've put in 6 samples, okay? And I want my render to be under 30 seconds, okay? So I'm going to let it render for 30 seconds. And once we render this in its absolutely horrific form with a lot of noise and so forth, I'm going to show you how you can put together that complex denoiser setup and get this to look slightly better. So a few more seconds to go. Boom. So 24 seconds. Now, this is not a production render, is it? Anyone? Anyone? So let's see how we set up the denoiser. Okay, so please, pencil and paper, write this down. You go to the render settings. I'm going to show you the whole process so you don't get confused. Render settings. You go to Effect, Denoiser, and you render. That's basically it. Sorry, I was just messing with you. So let's see what happens when we add the denoiser post effect. We're going to get the same rendering time, and then magic is going to happen, the magic that Intel does and Maxon works with them. And let's give it another few seconds. 13, 14, 15, 16. I'm sure you know how to count. A few more to go, and boom. So this is a 25-second render. And just, it's not perfect, we know, but it makes a significant difference if you're doing a 10-minute render or a 4 to 5 minute render, saving time. And believe me, if you put enough samples for this to render for 5 or 6 minutes on a normal 2019 computer, with a denoiser, it's going to look near perfect. So for me, the denoiser was one of the most exciting features. 2 clicks to apply it. That will improve your workflow because it's going to save you time. And it works on animations and so forth. Now, one little trick, I like to show tricks. What you could do if you don't own a third-party denoiser is you can actually use Cinema 4D to denoise footage and stuff like that. And I'm going to show it to you because I always like to show certain things. So I'm going to save a TIFF file of the noisy version. Let me go to Siggraph, Noseman. What? Let's go to the stylish watch. Let's go to a render. I'm just going to save it in here. So let's call it stylish watch, save, and let's see what we're going to do here. I'm going to create a, you can do it many methods. I'm going to create a sky object. I'm going to create a material and load in the color that one render. And that can be your movie. It could be anything you want. It can be that embarrassing video of your friend that you shot during the night and it was a bit grainy. And there you go, stylish watch and stylish watch. I don't want this. So 1920 by 1080. And what I'm going to do is apply this here and make sure I have no bit mapping, so no sampling. And just change the projection to frontal. So it's going to comply to this. So if I render this, which take just a couple of seconds, in theory, if I apply the denoiser, it's going to produce a better result. If it doesn't, just forget all about this, and there you go. So we can do an instant denoising of existing images, and this allows you to use Cinema 4D as sort of a compositor. So this is the denoiser. So the character animation stuff. Now, for me, that's extremely impressive because I am not a character animator, and I don't like doing dealing with weights, right? Painting weights and stuff like that. So this is a typical auto-weighting situation you would get with the current auto-weighting algorithms. And by shift double-clicking on this, so shift is not control. There you go. So you go to the auto-weight tab, which is yellow now. Set it to volumetric. Just leave everything as in their default state. And there's one little button which makes your lives much easier. If you click on in bind pose, it will actually find the bind pose by itself without you having to be in that pose in the first place. Click calculate, and it should take just a few seconds. And hopefully, there you go. And just with this auto weighting, you see we have near perfect. Now, it's not perfect, but if you're not a character animator, and you're a motion designer, or you do some other type of quasi-character animation, this is going to give you near perfect results. Okay, comparing this with the 2 or 3 hours you're going to have to tweak the weights, I think this is a great advancement in your auto weighting. Now, there are other surprises as well in the character animation workflow, which I'm not going to talk about now because I'm not a specialist by any stretch of the imagination. Let's go to the next thing. I'm just going to mention this. The timeline with keyframes, the actual dope sheet, has been rewritten for OpenGL. So just as a surprise, I'm going to let you try this out. If you have animations with a lot of keyframes which were a bit slow in playback when your timeline was open, you will see speed improvements that you will not believe. So they've done a fantastic job refining and updating the code, and now it's just a joy to work with the timeline open and scrub through and watch your multi-keyframe animations play like butter. Good. So let's go to the next little feature, which is called caps and bevels. I call it little feature, but that's an understatement. So let's just begin by making some text. Let's write here Cinema 4D, and hopefully I won't do any typos. Let's select one of my favorite typefaces. Makes everything look so cool. Impact and middle. So as you can see, our generators, when we are using the highlight, are now yellow. And that's because we've added, or actually, the whole functionality of the caps and rounding has been rewritten. And they've implemented a very modern and very powerful algorithm to do it, which allows you to do the following things. So first of all, we can have separate control for start and end caps. We can have separate visibility and separate controls, but I'm going to modify them both. We have all these modes: round, curve, solid, and step. And here we just increase the size. And by default now, what you will see is that the shape of the spline is being retained. It's the equivalent of the constrain mode we had in the previous version, but now it actually works nearly perfectly. There's always those edge cases where you can't solve algorithmically, but for the majority of cases, it will give you outstanding results. And not only that, we can go and control the shape of it, and we can create nice chiseled text and increase the subdivisions and so forth. And besides that, another thing we can do, and for me, I think that although this is an amazing algorithm, and it was worked on by our amazing modeling team in Maxon, thank you, you know who you are. Yeah, he's sitting there. We have a representative from the modeling team here, so feel free to go and congratulate them for the great work they've done. We have a preset system, so we have some built-in presets here. So you just click on this and it will just apply that preset. And you can save your own presets. So now you can just save them in the content browser, and you can have a list of all the bevels and rounding you want, and you can select any type. In this particular case, it's in the curve mode, where you can have a predefined 2D curve that defines the profile. And that, in my view, is absolutely fantastic. You know, you can make complex-looking text now extremely easily and have repeatability. You can share the assets with your colleagues and whatnot. Now, there's one more thing that's exciting for the geeks. I always have something for the geeks. Well, part of the presentation is for the geeks. Oh, it didn't start my watch. I've only been talking for 13 seconds, according to this. Anyway, the cap styles, we've added Delaunay triangular. Is it Delaunay or Delaunay? Nobody knows, actually. So, Delaunay. And this gives you a very good triangulation, which is based on the profile. So let me just put this on round, set this to 10, just simplify things. And let's go to my text, change this to subdivided to add. And what this allows us to do is add nice little organic effects without any artifacts. And it does solve a lot of problems when we have the rounding and we get those Phong artifacts. And with using Delaunay, we solve these problems, and they're really, really smooth. And one of the other things I really like is now that selections, you don't have to remember them. We procedurally create the selections for the shell, the actual extruded part, for the start cap, the end cap, the start bevel, and the end bevel. Bevel, semantics. And then we have the ability to export edge selections for you to use in Mograph and put things on the edges and so forth. So one of the examples I did, let's go and do it. So I'm going to use the start cap. So let's get rid of all these so I know what I'm working with. I'm going to go to my object caps, and let's increase. So this creates a uniformity. Towards the left, it creates an adaptive situation where it adds detail where you need it. It's a very intelligent algorithm, and hopefully in the future we'll see it applied in other places as well. But the groundwork has been done, and that's the important thing. So I'm going to go and I'm going to add, as usual, Alt-G. This is a PC, so you'll see me looking down at the keyboard because my muscle memory is Mac. I'm going to add a Mograph plane effector in deformer mode and watch things go totally crazy. Don't forget to change your parameter to the Z, which is the normal direction. And what I'm going to do, go to the fall off, because now with fields we can drop a selection in here, and now I'm pushing out only the part that's selected. So you can see that we can do interesting effects. We can mask it, we can blur it, we can do whatever we want. And at the same time, in here, let's try something else. Let's try some sort of random field here, and it's max. And here I'm going to give you a little introduction of the new masking system. I can use this mask, and not there. I'm going to remove the mask from here. I can mask using a random field. This is a new function, this little mask. And what you see here is what is going to be the standard fields interface. It's the new interface. I'm going to show you a few more things later on. But it's fantastic because you can see very clearly now what's going on. There's no more searching down in managers and clicking on tabs. Everything is in front of you. The interface is much cleaner, much faster. And I personally love it because I love working with fields. But now, as simple as this, we are masking that selection with a noise. So I'm actually adding a bit of noisiness only on the cap. So these kind of procedural setups now with a new fields interface, with our ability for our new caps and bevels to export those procedural selections and so forth, makes Cinema 4D easier to use, faster in production. You don't need to remember things. You can just work, and you should always remember that Cinema 4D is made for artists. It's not made for geeks. Sorry, geeks. There's stuff for you too, but predominantly we like the artists, the people that make pretty things. I'm just joking. I love the geeks. So I'm jealous of artists because I have no artistic inclination myself. I'm a total, totally incompetent when it comes to producing nice-looking things. Luckily, I'm smart and good-looking, and it kind of helps me have some sort of... Oh, good. You got the joke, didn't you? All right. So where were we? Oh, look at us. We're down here. So now that I've talked about the field interface enhancements, let me give you a bit more of an insight. And my usual go-to method is to do a very, very complex setup, create a matrix object. Pretty much that's it. Now, here's how things work. I'm going to apply a plane effector in its default mode, and I'm going to go and apply our typical linear field. Excellent. So, number one, with the new masking capabilities, you add a mask, and then you go and add another field, which you make it child of the mask, as I showed you. And now this field just masks the other one. It's as simple as that. And you don't need to do complex math and blending modes and all that. This is gonna allow you to do things much easier. It makes sense visually. So yeah, I'm pretty sure you're gonna have a lot of fun using this. Now the other thing which really, really excites me is the new way subfields work. And maybe some of you are not using subfields because the interface is a bit complex. If you start nesting them down the hierarchy, it gets a bit confusing. Well, I get confused, so I assume everyone does. But now with the new workflow, we have the following thing. So let's assume that this is our seed now. We have our seeding, and we're going to grow this using a freeze layer. So we will go and create a freeze layer. We need to make sure our freeze layer is, so 10.5, just need to make sure that I have a grow of larger than 10.5. I'll make this 12. And if I click play, you'll see that this grows. But it grows quite in a linear fashion. So in previous, in R20, when the freeze layer was selected, we had a tab here that said radius, which implied that we can go and add subfields, and it gave us a new field list, and you could go in and do that, and it would become quite complex. But now, look at this little plus sign. It actually gives us explicitly what channels we can affect with subfields. So no more speculation, no more searching through tabs. It's very, very clear. And all we have to do is say, OK, what do I need to do here? I need to put in a random field. I need to make it a child of the radius. And let's see what's going to happen. I'm going to make this bigger, because now we have values of 0, number 1. Number 2, I need to make sure, I'm going to make it normal, make sure that we have some sort of initial value that will allow the radius to grow. And I'm going to increase the radius a bit just to make it a bit more fun. And just like that, we apply that noise growing. It's a bit too fast, so I can slow it down. And now we get a bit of a noisy edge, breaking up uniformity and making it much easier to use with the new subfields workflow. So for anyone that's starting up on fields, or people that have been using fields and have been a bit confused with subfields, problem solved. So anyone uses fields around here? Fields, good. Then everyone should. You don't use fields. OK. So how do you feel about the new fields interface? Yeah. Editor, please add applause and screams, people tearing their clothes off. So one more little surprise. I'm just going to mention it, all right? But this is for the geeks, OK? I had one for you, at least one. We have a new amazing layer called the channel converter. And what this does, it allows us to take values from one of these buggers, like the value or the color, and transfer it to another channel. The power of this, I've seen some samples of this, and you will see over the course of September, we'll be releasing a lot of tutorials on University. And it's absolutely amazing what you can do by transferring different types of data from channel to channel. And to take a look, we can take values from color, red, green, blue, alpha channels, directions, RGB, and whatnot, and transfer it into anything else we want. So this is, I would say, the beginning of an attribute transfer system we have here, which is very artist-friendly and very geek-friendly, OK? So I keep doing that, assuming that all geeks are at home watching this in their basement in a computer, where the artists are here, sitting, exposing themselves. OK, so I love generalizations, by the way. So yes, that covers the field enhancements, the first layer of field enhancements. And now let's go and see some other fun stuff. So first of all, I don't know if anyone works with particles. Now, Xparticles has taken the Cinema 4D community by storm. It's, I would say, one of the most fantastic third-party plugins ever developed, and people are doing fantastic things with it. But not everyone has the need for so complex particle setups. And at the same time, some people can't afford to buy some software. So what Maxon tried to do is add a layer of capability to Cinema 4D that allows you to do certain things we couldn't do before. It will be very difficult to do. So number one are standard particles. Now, these standard particles are not very heavily utilized. It's an old technology, but it's, it's sturdy and simple to use. They've received a speed up. So I'm just going to extend my timeline and do what I shouldn't do. Just try and push it and press play. And you can see that we get good speeds for medium numbers of particles. Okay. Now, if you're wondering what you can do with these, there is a host of tutorials on University that show you can do dynamics, you can generate objects, and do all sorts of fancy things. So what I'm going to do in this case is introduce you to a new amazing force. So these here are standard particle modifiers. They add a plane deflector, destructor that kills the particles, friction, gravity, and so forth. And now we've added the field force. What the field force does is it allows us to add objects in a field list. So any field object or any other object that is supported by the field's context, and use that to control the particles. So let's see how complex this can be. I'm going to create a circle. I'm going to drag the circle in here. I'm going to set the circle to normalized value because this allows me to control them a bit better, and I'm going to press play. And now they spin because the circle is providing a direction, as you can see from that little interface over there, those little lines, which of course we can go to the display and increase the number of lines and change the length so we have a better idea of what it's doing. So let's go and see a few of the tricks we can do with this. The field force comes with 3 distinct modes. Add to velocity, which is a default, which does the following thing. Something is moving with a certain velocity, which means in a certain direction at a certain speed. Physicists, forgive me. And with add to velocity, whatever the field force is going to provide is going to be added to that. So we keep moving and it nudges us in a certain direction. Another thing we can do is set absolute velocity, which in this case won't yield any results, but it's used in other situations. And the change direction, that will absolutely exchange the existing velocity and direction they have with what we have here. So this looks interesting. Particles going around and around. Let's start pushing them forward a bit. How do we do that? Well, a linear field. We want to define a direction. So add a linear field here. Let's set this to normalize. Let's add the value on top and set my linear field to be minus z because we're going the inverse of that direction. And now we're pushing these particles this way. Now, because these are fields, this means that we can use all the field technologies in order to modify them. We can mask them, we can do all sorts of things. Plus, on top of that, if you want to go super geek, we have the fall off, which masks the effect of the force, of the field force, which I keep calling force field. It masks the whole effect. So the amount of control and art directability you can have just with these very simple setups is absolutely amazing. So let's go and do something else. Let's see if we can break this. I apologize, but I have to do these things. So let's get a random field. Let's set the direction, normalize it again, and add it on top. And you can see now they're getting this little jittery motion. And I can turn this off in the viewport unless you like seeing vectors. By the way, vectors are just like arrows that point in a certain direction. So let's change the field type. Just increase that. Let's get some more particles in here. And you know why we're getting more particles? Because we can. And let's extend the emission to 400 frames and their lifetime 600. So look at that now. So we are actually telling the particles, we're moving the particles using a Perlin noise. And you can achieve very interesting results doing this thing. And then you can add other forces on top. You can add friction and all sorts of other effects. You can mask them. What I like about this is that you change the noise. Now, not all noises will work, will give you an interesting result. I found that Voronoi 1 actually does an interesting little squiggly thing. And because I want to push it slightly more, I'm going to make my particles less, so just to make it go faster. And I'm going to go and add from my Mograph menu. And by the way, just inserting it in there, you've seen that the menu structure and the interface has changed significantly. And I'm going to talk about it towards the end. But anyhow, you can see I'm scrambling around to find certain things. It's because I'm trying to get used to it. So let's go and add a tracer object. So now all these particles are going to be traced. And I'm going to revert back to my Perlin noise. So not the linear field, the random field. Let's get a Perlin noise. Perlin noise. I love that name, Perlin noise. There you go. And now what I'm going to do is, why not? Let's put them in a volume builder. Let's drag the tracer in here. What you will see is now in the volumes, amongst other amazing enhancements, you can see some new buttons here. People are getting excited. Yes, calm down, everyone. Calm down. Okay, calm down. Won't believe what's going on here. So we can change the thickness of the spline along its length and do all sorts of other amazing things. So let's make this 5 and make sure always that the voxel size is smaller than the radius of your spline. I'm telling this mostly so I don't forget, which I do many times. And let's change this on this side. You can see it's getting skinnier. I'm going to use another method though. So now we have these growing structures going on. Nice little noises. Let's make this 3. Excellent. Let's add a bit of smoothing. So SDF smooth. Let's smooth it. Let's make sure we have 1 and set this to deflation flow. Play with these. These are very interesting different types of smoothing operations. It will give you different looks. Just adjust your voxels appropriately. And one last thing I want to do is go to the volume mesher and mesh this. And then, as per usual, I always do that. I'm going to add my favorite deformer, the smoothing deformer, to smooth this, make it nice and organic. And now you have something which is very art-directable because you're using fields to do it. You have something that looks extremely organic. And yeah, it's pretty much beautiful. Now, I did a test earlier. I rendered... Oh, yeah, let me go to my picture viewer. And let me load a render I did. So, oops, 19 Noseman presentation. What time is it? We're doing good time. Let's go to the, where did I do that? There you go, starts at renders. And I just rendered this with hair. It's the same thing. I'm going to add a hair tag, and you just get this nice wispy thing growing. There's no dynamism in this. You can go and add on top of this deformers and whatnot. But this is literally a 3-minute setup to get something like this. And just in case you were wondering, the way I did it was I just added a hair material to this. And you just render this, you change the hair material, and already you have a nice, interesting little graphic. And mind you, if you're adventurous, you can pipe this result in a MoSpline object and add on top of that dynamics or other stuff you want. And anyway, the combinations are literally unlimited. So let me go to my list. Let's see what we have here. Ooh, yeah. So if any one of you use thinking particles, now it's very powerful. It's not the fastest, and you need to be technically inclined to use it. But one little surprise is that we can now use these forces with thinking particles. So to show you how this works, I'm going to attempt something that one of our excellent developers that participated in the volume system showed me. And hopefully, if this goes well, it's going to be fun. I'm going to try and create a curl noise, particles moving on the surface of an object using a nice little purlin noise and leaving their trails and so forth. So, without further ado, this will introduce us to a new mode of volumes. I introduce to you the sphere. Okay. Volume builder. So volume builder, you will see here that we have a third type, which is a vector volume. Now, I'm pretty sure people are jumping up and down from joy right now, but this just records vector values, little arrows, which are in this situation are derived from the normal direction, and fills a volume which can be either a sign distance field, a buffer around the surface, or a volume and fill the whole thing with vectors. Okay? Now, this is a good thing. When you have certain types of data, you can use it in certain contexts. So as I showed you with the field force, it uses directions to push the particles. And by the way, the field force works with dynamics, it works with hair, it works with everything that the particle modifiers support. So what I did with the standard particles, you can do it with anything that has the ability to be modified by these modifiers. So that makes it even more powerful. Okay, so what I want to do here is I want the particles to move on the surface. This means that I don't want to move away from the surface. I want to move on the tangent. And if I want to do that, I will need to rotate that normal value 90 degrees. Someone told me that this is a simple thing to do, and I trust them. So what I'm going to do here, and I want to hear a cough if I'm doing it in the wrong way, I'm going to add a noise field. So I'm going to go to my create field and add a random. And what I'm going to do with this random is put it in here and do a cross product. A cross product is a sort of multiplication between vectors. But what the result is, and that's what we care, because if you do this, new folder, random field, cross, and put anything underneath, you know that the vectors are not pointing away from the surface. They're actually pointing in the direction of the tangent of the surface, which is the right direction to go for each point of the sphere or any object. Okay? If you follow this tangent, you're actually going to flow across the surface. So this is all nice and dandy. But let's see how we're going to connect this with the actual particles, because that's one of the questions. So I'm going to start with a standard particle emitter. And if time permits, I'm going to move on to show you how you can do it with thinking particles. So what I'm going to do is add a field force, and I'm going to add the volume in here, volume object. So let me go to my object. Everything's fine. Rewind, press play, and see what this does. I need to add to velocity maybe 50, and add more. You can see them now. They're diverting from their original direction. Okay? So you can see them moving in those directions. I don't want them to do that. What I want them to do is stay within that range. So I don't want them to go further in or further out. Once they get caught in that little field, I want them to stick around and move around. So what I can do is I want the same sphere. I can create another sphere. I'm just going to use the same sphere and find my instance object, drag it in here. So now I have a reference of the sphere. I'm going to set this to a buffer. So I'm creating a bit of a buffer. So we have two voxels for the one sphere, the one that creates the tangential movement, and I've added two more. So I want the particles to be stuck within that area. And I'm going to use one of the new layers here to invert this. So now everything is pointing in that direction. So let's see what this is doing. Let's change the field force to, is that the way to do it? Do I need to change that? To change direction? Fantastic. The other thing I need to do is use, and I actually looked at the developer right now. I'm going to grow this so the noise is a bit more visible. There you go. That's fantastic. Let's go to our field force, get this volume object, and I'm going to make sure that we have a kind of a linear interpolation. I'm going to make these move a bit slower. So the emitter, we have an initial speed. I'm going to make it 60 and increase my timeline here to, let's say, 600. Move this closer. Turn this off so we don't see it. And look at that now. Now we've got particles moving on the surface. And I'm going to stop emission at 150. That's good. I'm going to give them a good lifetime. And the last thing I'm going to add, just to make this a bit more fun, is to go and add a tracer object. Trace the particles. Create a spline that is growing on our surface. So although this, from conception, seems a bit complex, you can actually get away with this by making the rig once and just using instance objects to create this and this. I'm going to leave this as a surprise tutorial, how you can set this up as a procedural rig, which you can share with your colleagues, and all they will have to do is drop all the objects they need under a null, and that will be the shape these things are going to follow. And you can use anything you want under that shape. But this is a sort of a primer to how, although now we can do a lot of things much easier with a new field workflow, with a masking system, with a subfields, with a denoiser, with all sorts of other things, the caps and bevels, the improvement in the modeling tools, and the speed up of certain operations, we gave power to the power users. We're allowing people to do things, sit there, solve problems, technical problems, and start making fantastic stuff, very complex, with minimal effort. I just have a little anecdote. It's my anecdote, so you have to take my word for it. So I had a model of Manhattan, New York, a single model, and I had to apply a polygon groups to objects function to it, which is in the mesh. Well, we don't have a mesh here, but polygon groups to objects. It took a fairly long time to calculate because it was made from tens of thousands of objects. When I ran it using R21, it was 1,000 times faster. No, I'm lying. It was 900 times faster. I always exaggerate. So that particular situation, now it's not going to be across the board, but that particular situation was 900 times faster. So what you will find is with the incorporation of the new modeling core, which you can't see, it's not front-facing, but you will suddenly feel that a lot of the modeling operations you're doing are getting a significant speed up. So let me see what else I have on my list here. Let's see. Okay, I have about 13 minutes. So what I'm going to do is adapt this to work with thinking particles so that we can generate on the surface and use the same field force to affect the thinking particles. So here goes. So instead, I'm going to leave the tracer here, turn it off for now. Rewind. Now, I don't want to emit using an emitter. So bye-bye emitter. I want to emit using a surface. The easiest way to emit thinking particles using a surface is create a matrix object, set it to emit thinking particles, drop the object you want it to emit from. Yeah, I need to set this to object, of course, and drag this little guy in here. And in theory, we will get particles which are generated on the surface. I'm going to turn off this, and you can see those little crosses. Let's turn, got the volume builder, and the field force is over there. Now, if I press play, these are not moving, because by default, these are just generated, nothing happens. So I want to find a way to affect thinking particles using standard modifiers. We do need a bit of espresso here, but it's so simple. Number one, we have different arrangement of tags. It will take you 5 minutes to get used to it. It's much more logical. So programming tags, espresso. And what I'm going to do is type force. So this little node here, we just connect in this node any of the forces we want to affect the thinking particles with, and that's all you need to do. So do this, and then you tell it which group. P, pass, and we just select all. That's it. One link, two nodes. So now, in theory, this should move when I set the mode of this to set absolute velocity. And there they go. They're starting to move. And I'm going to turn on the tracer and make sure if you want to trace thinking particles, you go to your simulate thinking particles settings and you drag the group in here. That's all you have to do. And with this simple setup now, we are getting these particles emitted. Let's go and increase the number of these particles. Let's emit, let's say, 500 particles. And if you want some optimization tips, just go and change the ticks to dots, and this will just make your viewport ever so slightly faster. Let's go 800, see what happens here. And there you go. This is something we couldn't do before without some mental gymnastics and tweaking and so forth. And while this is playing, you can just go to the random field. You can change the noise size and make it a bit more. Let's make this 1200. It's going to change the size of the noise. You can make it smaller. You can animate it. So I'm approaching the end of my presentation. So I'd just like to do this and go to frame, let's say 240, and set this to 200, and scale this, rewind, press play, and I have no idea what's going to happen, but nevertheless, it's going to be fun. The noise is getting smaller. I'm going to make it go a bit slower. I'm speeding up now. Boom. There you go. And they're going to go, the swirls are going to get smaller and smaller and smaller and smaller. And for anyone that uses thinking particles, you can actually go and offset them and create a huge mesh just by modifying this. Or I can go to the field force and add something that pushes them out. How much time do I have? Because now I'm in experimentation mode. It's the part of the video they can actually remove if they want to. So let's add a spherical field on top of this. This is something I didn't plan to do, but who cares? Normalize, see if this is going to do anything. Woo, good. Let's make this inverted, so invert direction. Boom. Nice. And let's go and tell the field force, what should I tell the field force? Let's see if this is going to work, and I'm going to close my presentation if this fails. Rewind, press play. It's not what I expected, but anyhow, I don't care. This is the final thing I want to show. And I don't know if your creative juices now are in motion. I really do hope that this gives you some sort of idea of the stuff you're going to do. Over the next month and a half, we're going to be shooting out tutorials on Cineversity. The release is going to be available in about a month, I think. I hope everyone has a lot of fun playing with R21, and we're always open to questions. And I think I'm done. My name is Athanasios Pozantzis. I'm supposed to do this. So let me just go to my presentation here, and Noseman GR. So I'm Athanasios Pozantzis, the immortal Pozantzis. My handle is Noseman. If you Google Noseman, I come up first. If you want my business card, take a photo of me. And my Twitter handle is @Noseman GR. Thank you very much for being with us. And watch the rest of the show with all our incredible presenters. Thank you very much. Thank you.